Okay, these are two different kind of non-contact voltmeter, which will help you to detect electrical fields. For example, here's an LED light, and this one starts going off within a certain range. You don't have to touch the bulb, just have to get close to it. You can see, pull it out, and it'll turn off and on. This one I have to hold the button, but it goes off much sooner. I have to push the button on it for it to work, so it has to get sort of that close to the light before it starts going off. What's the difference? The difference is the one with the button here is a 50 volt non-contact voltmeter, and the other one is a 100 volt non-contact voltmeter. So the 50 volt is more sensitive. It picks up lower voltage. Now I want to show you this air ionizer. And as you can see, the 100 watt voltmeter can get real close to it and not go off. Then all of a sudden it goes off, right? You almost have to touch it. Well, again, the 50 volt non-contact voltmeter is far more sensitive. You hardly have to get close to the thing. This is a Honeywell air ionizer. And I'm way back here. I'm literally several feet away from the thing. So you can see, and it is definitely this ionizer, because we wave the other one around and nothing happens. See, until we touch, get in contact. So this air ionizer has a very powerful electrical field. Trying to capture them both in the image. I'm way away from it. So we turn it off, and the field is still going off. And you can actually follow the line. This is the power line here. The line is still active. Now I'm not touching it, I'm just getting close to it. Well, sometimes you have to touch it. Okay, there you go. It's kind of funny. There you go. Over here, especially probably because the carpet is insulating the field, it absorbs the field. Look at that. Especially this thing is still going off. So we follow the cable to the plug. Let's pull that plug out, and then that cuts it. So in order to get the thing to stop giving off that toxic energy field, you have to physically unplug it. Let's look at my cell phone real quick. My cell phone doesn't give me anything. It beeps when I press the button, but other than that, it's not giving me anything. Whereas again, the lights, you only have to get within so many inches of the lights for them to go off. If we turn the switch off, see here, this is what this is used for in carpentry, so you don't shoot a nail through a live wire and electrocute yourself. Now you'll notice again, the 100 watt is not as strong. So you don't want this 100, I keep calling it 100 watt, this 100 volt. You want a 50 volt, because this isn't picking up the live wire, and we know there's a live wire there, which is connected to these lights. You notice there's a bulb over here, which is not even turned on, but the current is still carried. So to get this thing to take the current off, we have to physically, again, flip the switch, and now the wire is not as bright. Okay, and the lights aren't giving off the field. Let's look at this fluorescent light real quick. There's a compact fluorescent light bulb. How close do we have to get to it? And this is with a 50 volt. Remember, there are more sensitive meters that you're going to want to find. Here's my TV set. Look at that. How far am I from the TV? I'm at least 1.5 feet from the TV set. Okay, and again, that current is carried through the wire. Can you see this electrical wire here? This wire is still generating the same electrical field. It follows the wire, so it depends on what's plugged in. Even these LED lights, these are LED lights, but they still have a very large field because they're connected to the same circuit as the TV set. So it's really important for people to get these voltmeters. Now watch, I turn this off. Okay? Now the field is diminished. It's not quite as strong. It's still there. But it's about 8 inches now instead of 1.5 feet. So, and it's still around the stereo down here. The DVD player, it's all in. So to cut these lights off, you would have to, again, physically turn off the circuit. It turns off the lights. And now they're not that bad. But this wire is still connected to the same plug. So you would have to, again, turn the whole system off. Because the TV is still giving off a toxic field, even though it's turned off. So you have to physically find the plug, turn the whole circuit off. Now what this does is it turns off the stereo, it turns off the DVD player, everything. It resets the TV, but it also kills the EM field, which is toxic. So when you're not using this stuff, it's important, unplug it. Buy a TV that has memory so you don't have to reset it, everything. Do not leave your stuff plugged in, or if it's plugged in, make sure it's plugged into a circuit breaker. Now look at this TV again. There's still static electricity on the screen. You know, you can feel it because it makes your hairs rise on end when you get close to the screen. So I'm just rubbing the thing across the screen. Okay, so again, this is a 50 watt. Now look, this is an LED light, but you have to get right up to it. Now this LED light is not connected to any other circuit, whereas the other LED lights I showed you before are connected to the same circuit as a few incandescent bulbs. Incandescent bulbs have a stronger electrical field than LEDs, although they are lesser than fluorescents. Okay, this is the Orgone Accumulator Handbook by James DeMeo. In it, in the table of contents, you will find in Part 2, the safe and effective use of orgone accumulating devices. Chapter 8, warnings and dangers, Orner and Door. Chapter 9, cleaning up your bioenergetic environment. So in these chapters, this is the second edition, by the way. You want the third edition. This is from 1999. The third edition is 2007. So in these chapters, pages 48 and 63, within those chapters you will find lists. So what do we have on page 48, chapter 8, warnings and dangers, the effects of Orner and Door? Fluorescent lights, television sets, computer or microcomputer, other cathode ray tube devices, microwave ovens or eddy current stoves, electric blankets, even if only plugged in and turned off, diathermy, x-ray machines, sparking electric motors, induction devices or coils, other electromagnetic devices, ionization type radioactive, smoke detectors, clocks, wristwatches, or other devices containing radioactive glow-in-the-dark materials, phospholuminescent materials which work on the principle of absorb visible light are okay, other radioactive materials or strong chemical fumes, airport radar systems, cellular, telephone, or microwave relay towers, very high-tension power lines, AM, FM, or TV broadcast towers, nuclear power plant storage facilities or nuclear waste dumps, military installations with nuclear bomb storage, past or present nuclear bomb testing areas. There's a lot here. So I'm going to show you my cell phone again. Again, there's no EM field, but it's still giving off radiation, a different kind of radiation. Electrical radiation are square waves. These are microwaves, which are more of the transverse kind. But I get arthritis just from holding this in my hand. So just because the meter doesn't detect it, don't let it fool you. You have to trust your body in this. I'm going to show you another thing. I have a Sonic Hair toothbrush. Okay, and there's not much light in here, but you can see the toothbrush. And look, just charging it. It's all charged wirelessly. They do this to make it waterproof. But again, the wireless, you remember in the list from Orgone Accumulator Handbook, involves induction devices. So it's not turned on. Let's turn it on. Now try it. It seems like it's not that bad. I'm not getting anything from the meter. So, are the induction device toothbrushes bad for you or not? We'll have to find out. Please check. Thanks, and thanks for watching this video. And protect yourself from toxic electrical energy.